The one thing I tell all my bootcamp students is that the user is the enemy, right? Yes, we make applications for users so that they can, use them for their lives and to make their lives easier and more convenient. But really, at the end of the day, the user is unpredictable. They will do what they will do, and we need to tell the computer basically like how is it going to handle all the different wacky things the user could do. Like take our guessing game. Right now, our guessing game works fine if the user does what we expect them to do. What do I mean by that? So I expect that the user will type in a number from 1 through 10, and then I'll be able to check that number against what the random number that I generated. But there's no guarantee of that. So like if I do like 5 and hit enter, okay, cool, too bad, so sad. That's a normal thing to happen. But if I come in and open this up, and let's say the user just hits enter. Let's say they don't type anything at all and they just hit enter. Then what happens is we get an exception. An exception is a general computer term. It's not just for C sharp, right? But an exception basically is in layman's terms, we ask the computer to do something, but it can't do it. All right. So things that could cause exceptions might be like dividing by 0. Right, like we ask the computer to divide by 0. Well, that's not a thing anybody can do. So the computer can't do that. Humans can't do that. Nobody can do that. So if you ask the computer to do something impossible or like illogical, it will raise an exception. So in C# and Visual Studio, what will happen is that it will stop on the line that caused the exception. So right now you see that line 9 is highlighted in this like greenish gray, and there's a red X. That means that this line, there was a problem. Right, everything up until that point was fine, but then line 9 itself, there's a problem, and it's an exception unhandled, meaning that we don't have code to handle this situation. Input string was not in correct format. Let's hover over user input. If you hover over a variable while you're in this sort of debug mode, you can see what the value is. If we hover over user input, its value is these 2 quotation marks here. It's blank. Well, we told the computer to take user input and turn it into an integer. That's int.parse is what it does. Take this string and turn it into an integer. Well, how do you take a blank string and turn it into a number? Like what number corresponds to blank string? That doesn't make any sense. So the computer is basically saying, I don't know what you want me to do with this. You gave me a blank string and told me to turn into an integer. Well, I can't do that. That doesn't make any sense. Here, I'm going to stop the program on line 9. I'm going to pop up this message saying exception unhandled and let you know there's a problem. So here's the thing though. Our program has crashed. Our program literally has stopped. Do not pass go, not collect $200. Once this unhandled exception is raised, we're just basically like sitting here twiddling our thumbs because the computer can't move on. So if I hit continue, the program stops. Well, that's no good. Like, what happens? So now our program basically will run only if the user does what I want them to do. But we just saw that there's nothing stopping the user from breaking the rules. When I run the program, there is nothing to stop me from hitting enter here and not typing in anything. There is nothing stopping me from typing the word aardvark and hitting enter. Right? As the user, I can do what I want. So because of that, we need to have some way to account for that. Now, if statements are going to help us. All right. So now, if we go back to our if statement, our original thought was we have the user picks the right number, give them a message. The user picks the wrong number, give them a different message. We were living in a world where our guessing game only had 2 possible outcomes, right? There are only 2 branches, 2 paths that the computer needed to follow in order to do what we needed to do. But that was wrong. We were naive. There actually are more paths. So if we think about it, like the user puts in a blank line instead of typing anything. That's a possibility, right? Like I just showed you, I could just hit enter and then bam, like user input is a blank string. So we need to check to make sure that they gave us the correct input. So now we have 3 different possibilities, but we only have 2. We have if and else. So if something, else is everything else. Well, we need 3. So let's change this up a little bit and let's learn a new keyword. So the first thing I'm going to do is I'm going to check to see, did they give me a blank string? If, parentheses, Now we're going to learn a new method, okay? This is another built-in functionality. We're going to do string dot is null or empty, and then put user input inside the parentheses. So let's talk about the string dot is null or empty user input. What this does is it's a Boolean, okay? So this will give us a Boolean. This will give us true or false. If user input is blank or null or basically empty means like empty string looks like this. It's just two quotes, like it's just quotes. There's nothing in it, right? So for example, string empty string equals, okay, that's an empty string. There's no letters or numbers or anything inside of it. It's just an empty string. So if string dot is null or empty, user input equals true, then we'll tell the user you need to pick a number between 1 and 10. So we'll give them a message basically like letting them know that they gave us, you know, poor input. All right? That's a good thing to do. Like let the person know like, hey, you didn't do what we expected you to do. All right? So if string dot is null or empty user input equals true, then do line 18. In fact, we don't even need this equals true. We can do the nice concise way with booleans and just leave that off and just put if string dot is null or empty user input. It reads a little bit better. But now we've got this other stuff down here. All right, if we like to chain more conditional statements together, we can use else if. So in front of here, I'm going to change this from if to else if. So now we have if string dot is null or empty user input console.write line. You need to pick a number between 1 and 10. Else if random number equals int.parse user input, then say that they won. Else too bad so sad. Well, this is a bit better now. We have 3 different conditions. All right, so we have 3 different pathways or trees that the program could go by, because now we're checking to make certain that, hey, like, did they actually like type something in here? If they didn't, we're gonna let them know like, hey, like that's not kosher, but the app will not crash. So if I run this and I just go here, let's say I just hit enter. You need to pick a number between 1 and 10, but notice how the application did not crash. Okay, we did not get an exception. It did not go into debug mode. There was no red X, nothing. It just basically just moved on with its life. So now we have a way to handle user input that goes against what we were planning, right? Remember, the user can do whatever the heck that they want to do. And the way we're able to do that is we have this else if. So now I have if, else if, else. And you can have as many else's as you please. It could be if, else if, else if, else if. Like you have 10 else ifs if that's what the situation calls for. You can have as many of these else if blocks as you'd like. All right, and then at the end, for everything else, you use the else block. Notice how if and else if both have parentheses and conditions inside, whereas else does not. Okay, that is a difference. So we have multiple else's, as many as you feel like, and then now our program is a little bit more robust. All right, if they put a blank string, they just hit enter, we no longer get that exception. We are able to continue to move on.